Hey all, thank you very much. Thanks for having me here. So I'm Tom Colvin. I'm CTO of Aptora, the app development agency based outside of London, not too far outside of London. I'm also a Google developer expert in Android. And my talk today is fun with Android and Bluetooth. Fun because Bluetooth is fun, because it is fun to write apps that have real-world consequences. You press a button and a light turns on, or you press a button and a fan turns on, or a garage door opens, or something like that.
Especially hearing it.
Yeah. Yeah, you will go home, I hope, and try some of the things that I'm going to show you, and you will be excited to see how much Bluetooth there is all around us. And I truly do hope that you have fun with it. So here's what we're going to be doing today. I'm going to talk to you a little bit about Bluetooth, and I'm going to talk to you a bit about Bluetooth Low Energy, BLE, how that works, its own specific terminology. It's got its own way of working and its own language that goes with it. Then we're going to have a quick hands-on, so I can shut up and you guys can have fun scanning and connecting and reading and writing, and I'll show you how we're going to do that. And then we're going to move on to the Android-y side of things. We're not going to do too much code here. I'm going to leave you with some repositories that you guys can play with afterwards. But I'm going to show you the basics of how Bluetooth works with Android. So, our story starts 1,000 years ago, more than 1,000 years ago. This is King Harald Gormson of Denmark, born 911 AD. There are two interesting things about King Harald Gormson of Denmark, born 911 AD. The first thing is that he is famous for uniting the disparate tribes of Norway and Denmark peacefully. And that's not something that had been done previously. It was a set of warring tribes as it was back in those days. And he united them peacefully and in fact became the king of Norway and Denmark. The second exciting thing about King Harald Gormson of Denmark, born 911 AD, I promise I'm getting somewhere with this, is that he had an interesting tooth. He had a tooth that was dark grey. But in the language of the time, there wasn't a word for dark grey, there was a word for kind of dark blue. So he became known as Harald Bluetooth. And the makers of Bluetooth, who came along 1,000 years plus later, decided to name the technology after him because they thought that it would unite, in the same analogy, it would unite the peripherals that are all around us wirelessly in the same way that this guy managed to unite the disparate troops of Norway and Denmark. So, gig fact to begin with. Ancient Nordic runes. This is King Harald Gormson's, or Harald Bluetooth's runes that represent his initials. This is the H or the R, like a pirate's R of Harald. And this is the B of Bluetooth. And this is how we got the Bluetooth logo. It's from this guy's initials. So, the big question is, did we manage to unite the technologies and the peripherals? Did we manage to make them work peacefully together? Well, not really. Because Bluetooth is immense. It's an enormous standard. It's 187 different standards, in fact, and just one of those standards has 3,111 pages. It's impossible for manufacturers to get it exactly right, which is why it's so flaky. But if you want to be the first person probably in the entire world who has read all of those 187 standards and understands them very well, then there is your web link. So let's look at how Bluetooth works. So this is Bluetooth. This is the original Bluetooth standard from 27 years ago. This is what we call Bluetooth Classic now, and it's hardly really changed over the years. The analogy for Bluetooth Classic is cups and string. There's a channel of communications between two parties. Anyone is free to transmit along that channel at any point in time. which means if you're not listening, you'll miss it. So, in order for Bluetooth Classic to work, the radios for both sides have to always be on. And these are high power radios, you know, the Bluetooth Classic goes actually a fair distance, and so these radios consume a pretty enormous amount of power. So we produce a technology that is great for sending files or streaming music, you know, when we're sending huge amounts of data, but it's terrible for something like a heart rate monitor that's got to exist in a tiny little space, or maybe a Bluetooth beacon that's got to, that maybe is in the ceiling rafters and needs engineering access to get to. These devices need to last months or even years. So the big question was, can we design a Bluetooth-like technology where the radio is mostly off? And that was a challenge for Bluetooth Low Energy. This is where Bluetooth Low Energy came in. Completely separate standard. Ignore the fact that it's called Bluetooth something or other. It is totally, totally separate to Bluetooth. The analogy with Bluetooth Low Energy is like a recurring meeting. Two devices, so we call it a peripheral and a central, but two devices basically agree a connection interval. That connection interval is anywhere between 7.5 milliseconds to 4 seconds long. And the two devices power up at the connection interval, at exactly the connection interval. They transmit any data that they need to transmit, and then they shut down again. So the Bluetooth radio is mostly off. It's only on for the tiny point in time where they want to transmit a little bit of data, and only on for when they're listening. And maybe the data that's transmitted is barely anything at all, because maybe the data that's transmitted is, I've got nothing to say, yeah, I've got nothing to say, okay, we'll close. The other thing about BLE is it's short range, so it's a low power radio. And one of the design aspects, one of the difficult things that they overcame in producing BLE technology was that the radio was very quick to power up and very quick to power down. So if you look at the power profile, it's just one big spike. There's not a ramp up or a ramp down, it's just a big spike whilst the radio's up, and then it's basically zero at any other time. So, like I say, BLE, nothing to do with Bluetooth Classic. There's no interoperability at all. It's developed completely independently. It's got the Bluetooth name because it got adopted by the Bluetooth SIG, the Special Interest Group, and it's part of the 4.0 standards. But as a result of that, they can actually, Bluetooth Classic and Bluetooth Low Energy can exist on the same radio chip. But it's important to understand that they are totally separate technologies. We get customers asking us, can you do us a Bluetooth app? And we go, yes, but you probably mean BLE. So, we're going to look at a little bit more about BLE and how BLE organizes its data in particular. So, here is a heart rate monitor. It monitors your heart rate. So, one of the pieces of data that you get from this heart rate monitor is the heart rate, the number of beats per minute. That piece of data is called a characteristic. Another characteristic that this heart rate monitor might have is where the sensor is located. So obviously a heart rate monitor might be on the chest, it might be in your neck, it might be on your wrist, but it could be anywhere anywhere located around the body that's sort of medically suitable. So that sensor location may be read, but also written to, because you might need to tell the device where it's monitoring the heart rate from. So characteristics can be read, characteristics can be written. Each characteristic has its own ID, and these IDs are defined in those 187 documents that I talked about earlier. Each one of the IDs is 2 bytes long. You could also create your own characteristic, give it your own ID, in which case it's got one of those great long UUIDs. But if you stick with the ones from the BLE standards, you get just 2 bytes. more information that you can get from this heart rate monitor. Let's look at battery level and battery time. So, two more characteristics. Battery level is like the percentage of battery left in the device. Battery time is literally the amount of time you get left on the battery. So, is it 5 minutes or 10 hours or 10 years? And again, they're two separate characteristics. Those are defined characteristics within the Bluetooth standard. But you can sort of see how these characteristics fit into separate sections. So there's a heart ratey type stuff and there's battery type stuff. And how these characteristics fit in terms of BLE is into services. So a characteristic is part of a service. So a heart rate monitor has a heart rate service and it also has a battery service. And what it can do is advertise the fact that it has a heart rate service without having to explain too much about what that heart rate service consists of. Because, you know, if you've got a heart rate service, then you're probably going to be able to measure heart rate, beats per minute, that sort of thing. When I say advertise, what these devices are doing is sending out a packet of data every now and then, again, on a connection interval, sends out an advertisement to say, I have a heart rate service. And then it goes back to sleep again. I have a heart rate service. And then it goes back to sleep again. Then the process of scanning for these services is just looking for those adverts. So if you want to scan for a heart rate monitor, you can sit with your phone and you can wait to be able to receive an advert on a connection interval that says, here, I'm here and I've got a heart rate monitor. So, as always with BLE, it's all about saving the amount of data that we have to send on these Bluetooth connections. Because if we save the amount of data, we save the amount of power, and BLE, Bluetooth Low Energy, is all about low power. Now, all of these services fit into a kind of server. One of the worst acronyms in all of IT, the GAT, the Generic Attribute Profile, is basically the server that encompasses all of these things. It's a big table of services. ATT is the protocol that is used, the one that describes characteristics and battery services and things like that, and how they're transmitted and received. So that's how the data is organized in BLE. We'll now go with a first hands-on. So what I have done throughout the room, I've got 3 of these devices, is I've got 3 contact beacons. They are Bluetooth beacons. So if you download a scanner, and here's one for Android, here's one for iOS, download a scanner app if you want to take part, and just scan for contact. All you have to do with a location beacon is scan it. It's there because you know it's there because it's sending you sending packets of sending advertisement data all the time. So scan for contact. It should be able to tell you, the app that you've downloaded should be able to tell you how far away you are from those Bluetooth beacons. So have a go doing that and see if you get any results. See if you can find one of the beacons.
You did a very bad job with putting 2 QR codes next to each other.
Yes, sorry, you have to. I did have it where one was in one corner and one was in the other, but I needed to put text on there in the end. So you should get something like that. Hey, you got it. Have you found the contact beacons? And you can see how far away you are from them, from contact.
Yeah, I think it says that, yeah.
Cool.
Like, are you not also like doing some sex talks there? Like, everyone down on this now and turn on your Bluetooth.
Yeah. It's a good idea. I'll save that for the next talk. So obviously you are not sending any data to my data harvesting contact beacons because all you're doing is scanning. But the next hands-on, yeah, you can send me some data. So I have a phone here, I have a phone here and here. I don't know when we're in a room full of like 100 people whether we're actually going to be able to connect to this, but if you scan for OnePlus 7T Pro, that's one of the phones I've got here, and the other one is just called Lundroid, you should be able to find a device that is running that particular service.
Oppio's iPhone, actually. And that's how he has.
No, basically every iPhone. Like I say, you would be amazed how much Bluetooth there is in the world, how much BLE particularly. But yeah, that's not the one. You're looking for OnePlus 7T Pro or Lundroid. And the first person to shout out my super secret password by reading that characteristic wins. Yes. Yeah, that's a custom service UUID, yeah. So
It's all in capitals.
it's, sorry, the password's all in caps, yeah. Have you got it?
Yeah.
Excellent. What's my password?
How do you see it? Attribute. How do I read it? Oh, no.
There should be, if you chose that app, there should be like an R in a circle to read it.
Okay. Custom hello.
Hello. Hello is my super secret password. Correct. So I'll give you another 30 seconds to see if you can connect. Can I ask you if you do manage to connect, because these are just two phones running, they're just normal phones, they're not anything special. Can I ask you to disconnect relatively quickly afterwards so that somebody else can have a go connecting as well? Somebody has written to the other service as well. Hello again. No, it's not that only one device can connect. Actually, BLE can support many to one, but it doesn't support it very well. And actually, if 3 people connect to one of these phones, then that's fine. Probably if 10 people connect, that's fine. I haven't tried it myself. I imagine if 50 people connect, it just isn't going to work. So it's more about bandwidth available on what is a very, very low power data rate system. Okay, so I'll leave these devices running. You can try connecting whilst I carry on talking. But what we're going to look at next is how Android manages BLE. It's a little bit complicated. It's one of those things in Android where things just don't really run smoothly. So what I'm going to do is I will show you the basics of how it works, and I'm going to leave you with a repository at the end of it. And if anyone has any questions, obviously ask me some questions or come and see me afterwards. So we have a system Bluetooth service in Android, and probably if you're an Android developer, you know how to get these system services. We ask a context to get system service, and the one that we want is context.bluetooth service. That gives us a Bluetooth manager object. If you've got Bluetooth disabled or the device doesn't have Bluetooth, that's the point where you get a null. So we start with this service, this Bluetooth manager. From the Bluetooth manager, we ask it for a Bluetooth LE scanner. That's going to be the thing that scans for BLE devices. Relatively simple to do that. We ask the Bluetooth manager for its adapter, and we ask its adapter for its scanner. So Bluetooth.adapter.Bluetooth LE scanner. And then we tell the scanner to start scanning. Now the interesting thing about that line is the scan callback that you see as the argument there. That is where things start to get a bit complicated. So this scan callback object is an object that extends scan callback, and this is where we get all of the results from the scan. So on scan result will be called on our scan callback object, and that will give us a Bluetooth device like that. So there's this theme within BLE. It's not too bad when we're scanning because there's only one callback for only one scan, and that makes it quite simple. You can sort of see how you can turn that callback into a nice maybe suspend function or a flow or something like that. But it gets a little bit more complicated a bit later. But anyway, this scan on scan result will return a scan result object. Inside that scan result object, you'll get a Bluetooth device, and that's where all the fun starts. That's the device that we can then start connecting to. So, taking this Bluetooth device, we can connect to it, and the last argument, Bluetooth GAT callback, is again another callback object. This one is a little bit more complicated than the last. So, doing connect GAT gives us a Bluetooth GAT object, and that Bluetooth GAT object is the thing that, that allows us to communicate with a Bluetooth device. So, here are some things that we can do with that Bluetooth GAT callback object that we passed into connect GAT. So Bluetooth GAT callback is just an object that extends Bluetooth GAT callback. As soon as we've managed to connect to it, it will come back to us with on connection state change. And it will say you have connected or you weren't successful in connecting. Once we have successfully connected, we can discover services. So with that GAT object, we say discover services. And on the right-hand side of the screen, that means our Bluetooth GAT callback comes back with on services discovered. Here are the services. When I say it discovers the services, that also means that it discovers the characteristics within the services. So you know at that point exactly what characteristics you can communicate with, write, read. We can read a characteristic by calling gat.readCharacteristic, and that comes back with a successful fail with onCharacteristicRead. And we can write gat.WriteCharacteristic, which comes back with onCharacteristicWrite. So that's where your code starts getting a little bit more complicated, because every single read or write, wherever it's performed, wherever within your app, always comes back to this one central callback. And writing, you know, the difficulty with BLE technology, writing apps for BLE, is being able to marry the response to the request that you made. Because really what you want to do is sort of write a suspend function that says, read this and get me the result, right? But, you know, it becomes a bit difficult to do that. So I'm not going to go into it because that's way too much code for some slides, but that becomes the next challenge once you've understood how this Bluetooth works. So I said I would leave you with some repositories. Again, 3 QR codes right next to each other, sorry about that. There's the server app on the right-hand side. That will run the same server that I've been running on my phone that you were able to connect to and read my secret password and write to as well. The client app is the one in the middle. So that's an app that demonstrates scanning and connecting and reading and writing to the server. And the one on the left is me. So if you want to connect with me on LinkedIn, that's where I hang out most of the time. Otherwise, that's it. Thank you very much for listening.